Welcome to Lesson 75 of Course 2 in Saxon Math. In this lesson we're going to talk about more complex problems relating to solving for area. And we're also going to learn how to solve for the area of a trapezoid. We have no vocabulary, so let's just dig right into this. This looks very familiar. You've all seen this before, and we've kind of learned how to do these, but we've been practicing these all along. In this lesson, we're going to find out how to do these little bit more tricky areas. So let's look at this example, and I'll do this one for you. We're going to find the area of this figure in the corners that look square. In this case, they are square, and they tell us that. And it's important that the question tell you that, because that's not always true. And then the dimensions are in millimeters. So let's figure out how I think the easiest way for me to do this is I'm going to break this up into a rectangle and a triangle. So I'm going to go ahead and bring it right down there. I think that's probably the best break. So I get my area 10 times 7. My base times my height is 10 times 7. So I know that the area right here is going to be 70. I know that. Now to find here, I've got 7 already. So if I take 16 minus 7, that's going to leave me 9 right here. And then if I take away 4 from 10, that's going to tell me that my height is 6. And 9 times 6 is 54. And 54 divided by 2, because it is a triangle, is going to give me 27. So I'm thinking I'm at 97 millimeters squared. There we go. I love it when I'm right. It is 97 millimeters squared. And all I did is I just found the area of the rectangle, and then I found the area of the triangle, and then I added them together. It's a little more complex than what you've done in the past, but definitely something that you have the skills to do. All right, let's look at this one here. We have to be careful when we divide these figures, because we have to avoid assumptions based on appearances. Although it appears in this picture over here to the right that this is a straight triangle, it really isn't. We don't have two triangles there. We don't. That it slightly bends right at that 4. So if we right here, it slightly bends down a little bit. It doesn't keep going. It doesn't keep going straight. It kind of goes down a little bit. So it's not a true triangle. So we'd get that wrong if we made that assumption. So it's important that we don't do that, and that we break it up into the two parts that we did before, because it doesn't bend straight down. So in this case here, showing you here, you could do it the way we did on the previous one. That would work also. It's still 97 millimeters squared. Or you could break it up into 3 pieces here. And this one here, you're gonna have 28. Down here, you're gonna have 42. That's still our same 70, isn't it? And then here's our 27 down here. So it still works out the same. But you can't assume, because watch what happens if we do. Normally we'd take 7 times 4 right here, and that would be 28 divided by 2. We'd say that was 14. And then we'd add these two together, or multiply those two together, and that'd be 160. And because it's a triangle, we'd divide that by 2, and that'd be 80. So we'd end up with 94 millimeters squared. Well, 94 and 97 aren't the same answer. So we would be wrong in our assumption if we thought that that was two triangles. So you got to be very, very careful the way that the directions read. All right, so let's find the area of this figure. Corners that look square are square, and the dimensions are in centimeters. This one has 3 ways of figuring it out. Pause the video, see if you can do it on your own, and then start it back up, and I'll show you what I would do on something that looks like this. Okay, let's take a look at this. Couple ways of doing this. I think the easiest way for me, because we've only got one piece missing, is I'm going to go ahead and extend this out. All right, I'm going to go like this. So now I've got one great big square with this corner missing, right? Well, the whole square is 10 times 10. So if it was a square, the area would be 100 centimeters squared. Now, but I'm not done yet, am I? Because I've got a little missing corner here. And what's missing from this corner? If I've got 6 and it's 10 wide, the base is 10 wide, then that means that's a 4. And if it's 3 here, then I know I've got another 7 here because it's 10 tall. So 7 times 4 is 28. And because it's a triangle, what am I going to do? That's right, I'm going to divide it by 2. So that's going to be 14. So I know I got 14. So I've got a minus 14 because I got 14 missing right here out of my square. And when I do that, I end up with 86 centimeters squared. Is that the way you did it? You might have broken it up several different ways. You may have done it this way here and did it in 3 parts. Calculated this here. This is going to be 7 times 6. This is going to be 42. And then you got 10 times 3. This will be another 30. And then you got 4 times 7, which is 28, divided by 14. And then added those all up. Or you may have done it this way here. Here's my way right here. That's the way I did it. And I think that's the easiest way when it's just got one little tricky jaunt there that you have to deal with. When it's subtracting one, I like to do it that way. So hopefully you came up with 86 centimeters square also. All right, now let's talk about trapezoids. Trapezoids do not have two bases that are the same length. In other words, this top here is much shorter than the bottom. So we can't just do base times height to calculate a trapezoid. It won't work because we have 2 different bases. We have a base, they call it base 1, and they call it base 2. So what we need to try to do is try to get an average of the 2. And once we do that, then we can calculate. Because if you'll notice here on this dotted line, that if we take this little piece right here, it'll fit right there. Take that little piece here and it'll fit because because this right here is an average, right? These aren't. So you've got to, so the formula for a trapezoid is the base 1 plus the base 2 times the height, times our height, and then we've got to multiply all that by 1/2. Okay, so average of the bases times the height, right, is going to be, we've got the average. So that's where the times the 1/2 comes in, is getting the average of the 2, because you're going to have 2, 1, 2. So we're dividing by 2, right? Dividing by half. So we've got to divide 2. So let's look at this. Okay, so for example here, so here it's just written out. You got base 1 plus base 2, and here's our height. So you'll always be given the height. You'll know what the height is. They don't make you guess that. A little later on, we get a little more advanced, and you may have to calculate the height yourself using the hypotenuse. But for now, we won't do that. We won't do anything that hard. We'll always have a base 1, a base 2, and we'll always have a height. So looking at this one here, let's take our formula. Our formula is area equals our 1/2 times the base. The average of the base is base 1 plus base 2 times our height, which is 6. So now let's plug it in. So area equals 1/2. Right, now our first base is 10. You see that right here? There's our first base is 10. Our second base is 7. So 10 plus 7, and then we're going to times that all by 6. Now, because that's our height right here. See that? That's our height. Now, because 10 plus 7 is going to give us a weird, when we divide that by 2, it's going to, 17 divided by 2 doesn't really work really well, right? If it was 16 divided by 2, that'd be 8. That'd be really easy. But because it's not, we're going to wait on this, okay? We're going to take 17 and times it by 6. Okay, so we're going to use properties that we can use, and we're going to combine this first and do 17 times 6. That's a 2, and that's a 102. So we got 102. Now we got 1/2 times 102. Now it's easy. So now we have 102 divided by 2. We know that the area of this trapezoid now is 51 centimeters squared, because 51 is half of 102. Does that make sense? I sure hope so. All right, let's see if you can do this one just averaging. Okay, so you're going to estimate. Estimate says don't do it exactly. This is a very hard problem if you do exactly 5 feet 11 inches. You got to convert it all to inches, then get your averages. It's not asking you, it's asking you to convert it. Pause the video, see if you can do it before I show you. Please do it yourself. Know how to do this. Go. All right, let's take a look at this. Let's start out getting our estimates. What's that? That's the closest. Is that closer to 5 feet or is that closer to 6 feet? That's closer to 6 feet. So I'm going to put my 6 feet up here. That's my top base. Then what's my height? Am I closer to 7 feet or closer to 8 feet? Closer to 7 feet. So my height is 7. And then my bottom one, this one here, you can see is 10. All right, so now we're going to take our formula. We got our area. Our area equals 1/2 our base 1 plus our base 2 times 7. All right, so 6 and 10. 6 and 10 is 16. Well, 16 is a little bit easier now, right? Because we know that 16 divided by 2 is 8, and 8 times 7 is 56. So 56 feet squared, we're done. Or we could do 16 times 7, then divide by 2, but that's going to be the harder way. So in this example, because 16's divided by 2 evenly, nice, good, solid, even number, let's just go ahead and do this multiplication problem first and take our 16 divided by 2 and make it 8, and times our 8 by our 7, our height, and end up with our 56 feet squared. All right? There you go. You guys can do this. That's all you need. There's your problems. Work these out tonight. Submit them to me online. Bring your questions tomorrow in class. We'll work on them together. Thank you for watching the video.